Welcome, everyone. We are starting the 81st NMRG meeting in this IETF 22. So I am Laurent, and sitting next to me is Jérôme, co-chair. Welcome. Let's get started with the usual note wheel. So there are a few announcements very important when we participate into the IETF and IETF work. First, on intellectual property. So be aware that the IETF follows the IETF intellectual property rights disclosure rules. There are a few of them that you can look into these notewell slides, and you have the more detailed procedures that are available in the link. The important thing is that if you participate into the IETF, you agree to follow the IETF processes, so to make timely disclosure of any IPRs that you are aware of concerning the work. And there are a few elements to follow on. Next, concerning audio and video recording. So the IETF routinely makes recordings of online and in-person meetings, including audio and video and photograph. If you participate in those meetings and choose to wear a not to be photographed lanyard, then you consent to appear in such recordings. If you speak at a microphone, appear on a panel, or carry any official duty as a member of IETF leadership, then you also consent to appear in those recordings of you at that time. If you participate online and you turn on your camera and your microphone, then you also consent to appear in such recordings. Privacy and code of conduct. So as a participant or attendee in the IETF activity, you acknowledge that written, audio, video, and photographic records of meetings may be made public. Personal information that you provide to the IETF will be handled in accordance to the privacy policy that you can find at this URL. And as a participant or attendee, you agree to work respectfully with other participants. If you are aware of any misconduct or issues you may face, there is also an ombuds team that you can contact for any reason. And you have also references to the different IETF and IETF code of conduct and anti-harassment procedures. An important statement also, the goals of the IETF. So the IETF conducts research. It's not a standard development organization. And the IETF focuses on longer-term research issues related to internet technologies, together with the IETF, the parallel organization, which itself focuses more on shorter-term issues of engineering and standard setting. The IETF can publish informational and experimental documents in the IRFC series, but the primary goal is really to promote the development of research collaboration and teamwork in exploring research issues related to internet protocols, applications, architecture, and technology. And you have also some information related to participating as an IETF participant in the following. So that's it for the announcement. A few administrativa, so you can find also useful links. Don't forget to also register on the on-site Meeteco application or the web version of it. It's important to record participation, and if you want also to join the Q&A comments, you need to use those applications in Meeteco to join the mic queue. For people that are also willing to help taking notes, we have the usual notepad that is available, and so please feel free to input any important statements and comments that you feel useful. Okay, let's go with the agenda for today. Hopefully we will fit. We try not to pack too much, but we still have a quite number of presentations. So we'll start with a few updates on the research group side. It should not take too long. Then we have Network Digital Twin, the concept and reference architecture draft that is moving forwards to IRSG. So the authors made an update. We wanted to also highlight the changes in this draft. Then we have also another take on Network Digital Twin with practical consideration and examples by Marco. Another set of presentation today will be focusing more on the use of AI for network management. So we have also a AI for network operation presentation looking also into some use cases. Then we have a couple of presentations looking into the use of large language models for network management and operation, and also to keep the human in the management loop. We received also a number of, let's say, call requests for presentation, and there have been a number of, let's say, LLM or AI-based proposal in the IETF and in the IRTF in recent meetings. So we would like also at the end of the agenda today to open a discussion for the group, how we would like to tackle these topics. So you have some questions, and we would like also to take time at the end to go over this, let's say, this discussion and how we would like to handle the topic in the group. So some status of the research group in terms of documents. So we have a number of progress to report. So we have the green networking draft, challenges and opportunities, that is going into the second IRSG review. We got the outcome of the first IRSG complete review requesting some updates. So this is expecting to move forward now anytime soon. We have also documents going into IRSG review. The draft on research challenges to couple AI and network management is ready, to address the IRTF chair comments, and is now ready also to enter the IRSG review. We have also another document that will be presented today, the network digital twin concept and architecture, passed the research group last call, and is now also ready to go to the IRSG review. And finally, we also have recently adopted research group documents after IETF 121. So the one on the consideration of network/system for AI services is now an adopted research group document. And the other document on the use cases for intent-based networking is also now a research group adopted document. So congratulations to the authors, and we are going to also continue to move these documents forward in the pipe. General views. If you're familiar, we were also spending some time in the last couple of meetings to look into an updated research agenda for the group to focus the activity towards a number of topics. So this is now final, and we are pushing it to the IRTF data tracker in order to make the updates on the web pages. In other news, I will be stepping down in my role of co-chair. So this will be my last meeting sitting here. And then after that, group steering will be handled to Jérôme, and we will also, together with the IRTF chair, see how to make a call for a new co-chair for the group.
And I would just like to thank you for your service for very many, many years in this role.
Thank you, Colin. Much appreciated. Thank you, everyone.
I want also to thank you so much, Laurent, for working with you first as an NMRG participant when I was not co-chair yet, and then with you as co-chair. It was a very good experience to work with you.
Okay. I think we are done with the research group news aspects, and we are going to start with the agenda, technical presentation part. So the first talk will be the updates on the network digital twin architecture draft. You can use it if you want, and try
to. Good morning, everyone. This is Chen Zhou from China Mobile. I will present the draft update of network digital twin concept and reference architecture on behalf of our co-authors and contributors. First, a quick recap here, and we know the RG draft has started its publishing process in last November, and after fixed all open issues raised in mailing list, NMRG meetings as well as in GitHub. And specifically, we collaborated with ETSI ZSM to align the concept, definition, and the reference architecture of network digital twin. And finally, we reached a sufficient consensus. And regarding last call, the last call ran from November to December last year, and we'll get comments from several experts. The comments are all in citations, NDT element definitions, and some spelling errors, etc. I should say thanks to the expert Wei, Ziyang, Jingjie, Gao, and thanks for your support and comments. Then we discussed and cooperated with our authors and contributors in GitHub and mail list to address the comments. Here is our activity. We opened one issue in GitHub and for pull request to address the comments. And totally since last February, we totally opened 10 of issues and 29 pull requests to address all comments from the mailing list and the meeting comments. And all of them are closed now. Regarding the latest changes compared to previous version, we made the 3 types of major changes in version 10. Firstly, we added more citations on digital twin and the network digital twin. Secondly, we refined the elements in section 4. And thirdly, we made numerous editorial changes and some general readability updates on the draft. Here are some details. First, for citations aspect, in section 3, we added more citations of digital twin and network digital twin, including SDO terminology and several academic papers regarding digital twin in industrial fields and also digital twin in network fields, the recent progress. And we also added academic workshops in the text, and such as IEEE norms, TNT workshops. Thirdly, we add citation on SDN with RFC numbers. And finally, we added citations on network modeling to reflecting latest progress in IETF and NOP. Then in section 4, we refined the key elements of network digital twin. We combined paragraphs to remove some redundancy, and we also moved element logic forward to ensure a unified description of the 5 key elements. And according to the comments from the last call experts, they suggest us to add interaction between elements, and also suggest us to add arrows in figure 1. Well, after check, basically, we think that figure 1 does not aim to provide a workflow here. Instead, it only focuses on the key elements that would comprise of the NDT. So we just respond and clarify in the mailing list, and no change was done here. Regarding editorial changes, firstly, we corrected all spelling errors commented on in last call, and inspired by the experts' findings, we co-authors conducted a thorough review on the entire article once again to find or correct some changes, some errors. Like we deleted temporary info, like discussion venue, and we updated and reordered acronyms and abbreviations, and we added the full name of the variations that only appear once, and we also unified the NDT descriptions throughout the text as well as all figures. So that's all for the changes, and now the draft has now addressed all comments from last article, and we also believe that draft is ready for RSG review, and now we are requesting the document publishing further process. And that's all for the update. And I will take this opportunity to share some points on the gen or generative AI or AI foundation models on natural digital twin. I believe that it can be candidate research directions on natural digital twin in future. And I think the large model or foundation models can accelerate the construction of natural digital twin. We know data and modeling are the most important two parts for natural digital twin. And from the perspective of data, we think foundation model or generative AI can help generate data efficiently and then optimize or enhance the data effectively. From modeling perspective, think that foundation model can help quickly build the basic models, including natural elements, natural topologies, and then the foundation model can also help quickly inference downstream tasks and make decision effectively. A research example here on data generation and optimization on for natural digital twin performance modeling. And our motivation here is that we know the practical network data is in shortage somehow, and even unavailable sometimes, especially considering the data with high security or privacy level. So our goal is to find some method to generate the data, then optimize data, and to reduce the dependency on the practical data, and even keep the accuracy of the or quality of the data modeling or network modeling. We have just posted initial draft with initial framework on our goal, and some detailed generating or optimization or enhancement method still need to be expanded in future, and we welcome the experts to join us on this work. So that's all for my presentation here. Thank you for listening, and I welcome any questions here.
Thank you, Shane. Do we have questions from the participants? Okay, so I'll go first. First, thank you, Shane, and to the authors for the latest revision. This is a good also quality work on the draft before entering RSG review, so thanks for sticking with that. I think the work is ready now to go to IRSG for further publication, and it's a good milestone that the group has reached on this topic. It's an interesting take on the reference architecture, so it's useful, and we see also that this work is already cited outside of the group, so it's also a good recognition that it has some form of value. So looking forward to see the next step, IRSG comments on this draft and eventual publication. Maybe a comment on your few last slides that you were also highlighting with the use of different techniques for data generation or modeling for network digital twin. So this is very interesting. I mean, very important that you raise this now, because we need to continue to have a flow of inputs to the group. If network digital twin is a topic of the group, what are beyond the architecture? I will say what are the other topics of research that on this topic that the group wants to follow. So the aspect of data generation and the aspect of modeling aspect are very important. So thanks for bringing that up. just like to make a couple of technical comments on that, especially if you can go to the next slide, I think. Yeah, because for me, I see two situations. One is you have say, a good digital twin of your system, and you have some confidence that it's accurate enough, representative enough of the network behaviors or network interactions, the element that you want to model, and then you could use it to actually, use the twin to generate data for different test case or what-if scenarios. So you see, the prerequisite is that you have already the twin and you use the twin to generate data. There is, I think, another side, which is you want to generate data to actually build the twin. So it's, I think it's a different assumption, and you are not going to look into the same use of data generation in both cases. So maybe it's useful also to try to situate what you want to achieve and separate well, maybe in the draft also, that this is different goals.
Good point.
With respect to the status of the twin. Either the twin is already there and accurate enough, or you're actually trying to improve, which is more on the data optimization and the data modeling part, what the twin is going to look like.
Good points. On here, we just focus on the one side to generate data for digital twin, but your strategy is also valuable. How we can use digital twin to help generate data. That's a good point. We will continue our research later. Thank you.
Okay, thank you. So, if there are no other questions or comments. You're allowed.
Thank you, Mr. Chairman. This is Diego Lopez, Telefónica. Now, it's a comment in general. Whenever we are talking about digital twins, etc., I see the term simulation probably so often, and I insist very much on this. In most cases, and especially when you are trying to generate data that makes sense for something like a generative model, I try to use always the term emulation rather than simulation, because a simulation is something that is abstract. You are talking about events, you have your Markov models, you have your queues, but you are not generating packets, or you are not generating, I don't know, addresses or this kind of situation. That's simply a recommendation. I always insist my team to use the term emulation. That is, in my view, is more realistic to reflect the topology. Even if you're using virtual environments, you're using Kubernetes, you're not using the real boxes, but at the end it's more an emulation than a simulation, which is what this is the interest of a digital twin. That's.
Thanks. Yes, your finding is very is correct, and for each kind of models, they use different data. Actually, some model may use the raw data or packets for the verification or for the modeling. But some others just use statistics data, like flow metrics or even logs or packet stats. So depending on what kind of model you are using, we can choose to generate what kind of data. Thank you.
Comment from myself, just to continue the discussion. Not as a chair, I a bit disagree to say that we have to exclude simulation and just keep to emulation. Yeah, but I think we discussed a lot of that. It really depends on the final application or goal of how you want to use the digital twin, because the realistic the properties that you want to achieve depends on that. Second, I'm not sure that emulation is always more realistic than simulation. For example, you take the example of generating traffic or packets. Yes, you take Kubernetes. You can make, let's say, environments that emulate your network, and so you will have real traffic. But if your goal was to somewhere have a realistic network, a big network, large network, for example, with latency, and so you cannot so much control. While in simulation, you can completely control, for example, the latency ordering of packets. You can really mimic what will happen. So it really depends on your final objective. I think both are valid. Yeah.
Can I respond to that question? So, Dan, I did have my hand up. You know, these terms are not synonymous. I think we agree that they have different purposes, therefore different functions, so they're not mutually exclusive. So a network digital twin can do both. It can emulate real-time what's happening in the network or what has happened, and a simulation is maybe what might happen. It's the prediction. And whereas an emulator may be derived directly from state that's exported or received from the network, a simulation will be the adjustment. It may be driven by a human to modify parameters or some kind of sensitivity analysis where you insert a new traffic matrix to see what the effect would be. So actually a network digital twin could be both a simulator and an emulator. So as long as this type of document describes what those terms mean in the context of a network digital twin, I think we're good. And then other documents can refer back to them and reuse the terms.
Thank you, Dan.
Marco, just a quick comment. So I think I can agree to everything that has been said. So I think both is right, simulation and emulation. In that aspect, I agree that the term emulation is maybe more appropriate because it's a big problem, which is access to realistic data, right? Where to take realistic data from to feed or train a twin, right? So I think the artificial generation of realistic data in real time, that's something that can be associated with machine learning or Gen AI as proposed here. And I also think this is more falls under the category of emulation. Simulation, it's more about accuracy, but maybe not in necessarily real time. So
I guess that at the end we are more or less in agreement. Just let me remark one thing. One of the problems that we have found trying to address this kind of data generation is precisely that the great challenge is to combine in the same environment simulation modules and emulation modules, because that would be perfect at the end. Or well, talking about interconnecting twins, simulation-based twins, emulation-based twins, and make them work. Because if we manage to do so, I think this is a great challenge because it requires translations that are complicated. Is something that would be we would achieve a real a significant step in the use of this. My concern was about that if I have had too many times colleagues that say, no, what you're doing is just a simulation. No, it's a simulation that collects some data from the from the outer world. And well, it's about pushing hard that it's not only simulation, we are able to emulate and mix and mix. I'm not saying that, I'm not asking for ditching simulation.
Hi, this is Oscar González de Dios Telefónica. So I think getting back to one of the points that you mentioned before about having a correct description, we had some similar issue when doing the work in CMAP for the use cases of emulation simulation. So we ended up having the definition there of what was exactly the simulations, emulations. So I suggest even one, taking a look and maybe another one extending it here, because here this is research. So here you can really extend more. So even you can describe the types of simulation and the types of data that you can either generate or replicate with the simulation, because the simulation you can, I guess, you want to use it in the digital twin for two things. So one of them is to generate data for later on checking, and another one is to validating the behavior. And I guess for validating the behavior, even both the emulation and simulation are fine, but discrete event simulation can combine with mathematical models also. For example, if you are working with an optical network, you will require a lot of mathematical models. And there, you are, the assumption is that you will use simulation to, in, let's say, a short time of period in the reality, you can expand it and you can take as long as you want, while in the emulation, you are always assuming that you are moving in real time. So my suggestion is just to take a look at the CMAP, the definitions there. Maybe here you can expand it, you have room even to have a full document explaining that in detail.
Okay, good, very valuable discussion on simulation and emulation. Actually, I just share my point on this, and there are many definitions on simulation and emulation based on goals or methods here. And another angle is that for emulation, we need to focus on its time sequence, and need to look up into its procedure. But for simulation, we just focus on, most importantly, focus on its final result. So its performance. So that's just an angle on this difference. Of course, there are many other differences depending on goals. But back to our natural digital twin, we think that they are both our goals. To use digital twin to get our goals, either simulation or emulation, depends on our requirements or our purpose. Thank you.
Thank you. We need to conclude now and move to the next presentation. Thank you, Shane.
Thank you, Chair.
The next talk will be by Marco, an update on their work they have been doing into practical implementation and experience they want to share.
Can I proceed? All right. Okay, so I'm Marco. I'm talking about this draft on behalf of my co-authors Martin and Nia. I don't think they can join online because it's in the middle of the night. Anyway, we can clarify everything else offline. So the first time we could talk about this work in Vancouver, mainly we had in mind moving into the spot a little bit more the practical realization and implementation of network digital twins, which is everything but trivial. So at that point in time, we brought one use case, which was a practical implementation of a software-defined networking twin. And we got quite a good amount of comments, views, opinions, feedback, discussion, even after the session. This is exactly what we wanted. So proceed. All right, in general, network twins, they gain more and more traction. So you see it not only here, but if you see any white paper about visions, how future network can be administered, how to make them fail safe, how to automate the operation of them. So you always see digital twins popping up here. And as said, we wanted to discuss a little bit more the practical aspects. We don't want to have unidirectional presentation of what we experience during lab experiments and our work, but we want to foster discussion. That's the point. So short background, the very first draft that we presented in Vancouver, we had a list of practical challenges for entity instances in general. So we talked about a kind of framework that complements the architecture draft. And we talked about network twin awareness from user point of view, because you always have a level of abstraction. You need to be aware of that. Then which models apply in particular if you move from discrete event simulation towards machine learning. So which model is more appropriate to your needs? And there is not one model that counts for all, but you really need to tailor that to what you want to make use of the MET. Probes versus enforcement. So how does a user or a client make use of a twin? Is it just a probe, get feedback, and then take a decision that's to be enforced in the real network? Or do we have something like intent, that the twin automatically takes a decision based on your intent and then enforces? So there are a couple of differences. Also scale and accuracy, if you have one big twin or if you build multiple models that federate with each other, which has several advantages that we talk about. Then, as said, we had one implementation of a software-defined network twin that we talked about, and there was quite a good amount of feedback and discussion. Now, before this IETF, we published version 1, which has a bit of a new structure, just to put a little bit more the experiments that we conduct into the spot. And we added on top of the SDN-DT 2 new use cases. One is based on quantum key distribution and the other one on a 5G mobile system. Very particular cases that we address here. You find no recommendations for models, but some thoughts, and we want to foster discussion, as said before. So quantum key distribution. So it's a very hot topic, and it's very hidden kind of research being done. That has various reasons, and there are mostly test beds with varying accessibility. That has a reason that the fundamental components, the quantum communication modules, are rare, they are expensive, and they are not easy to access for the community to build software on top. Right? Also, the whole system design framework features, it's not yet clear. So there are standardization effort behind in ITU or somewhere else. It's not yet cast in stone, and experimentation above these rare quantum modules, it's something that is needed. And if you don't have them available, I think a digital twin of these modules could help. Short insight into such a system. So on the very bottom, you see the rare components, the quantum communication modules, which have a quantum communication channel with other modules, which is limited in distance. So let's not dig into the details now and here. The point is, on top, you need a system to distribute the quantum keys. And these key management systems that you see here, you have multiple instances, and you have protocols operating in between, and then you have southbound protocols towards quantum modules. The whole management system above is about retrieving the keys and sharing them with remote sites. So these quantum modules, if you cannot access them, how can you make them available for the community to develop software on top? So you could extract a key generation time-based vector and use that and make it available. Or you could really model such a quantum communication module either from the vendor perspective, there are a few, or if you are lucky enough to have enough money and get such a module, you could build a model on your own. So that's the idea behind. And machine learning is a good approach to do that. We are just starting to look into that. We are in the fortunate position to have access to these modules in smaller projects, but I think to have a good community development on the upper box, these modules by models should be made available to the community too. Another case we want to talk about and added a bit of content into the draft is 5G. So a long time back, mobile communication systems were made out of hardware blades. They had a clear resources assigned. They had a clear performance limit, such as busy hour call attempts that you can reach. Then you should add load balancers, these kind of things. So today, everything is software, to a large extent. Here, performance figures depend a lot on the deployment, right? If you deploy on a single server, distributed on top of a hypervisor or in a container runtime. So it depends a lot on what you can achieve. And so network twins are being considered for these systems to have a real-time synchronization with a real network, and then to probe some changes or see if there's a danger of a failure. So I think it's of high interest to avoid failures in such a network. And if you have a twin that could model and anticipate particular danger situation to run into failure, and then to counteract or raise alarm, that's something that could be useful here. Of course, offline network twin versus real-time network twin. Offline network twin, you have a network twin of a 5G core, for example, that models or mimics the behavior of the 5G core very accurately. But if you have a real-time NET, you always have to synchronize the twin state with a real network. That's another kind of challenge here. And the use case is different. If you want to have an offline entity, you could make use of discrete event simulation models, right? Because time doesn't really matter. But if you have time as a KPI in your use case, then you should not waste time with discrete event simulation because the failure may happen in the real network before you could simulate it. But AI and machine learning models could help here. So what we are experimenting a bit is about taking one or a small group of network functions from the 5G core, model them by means of machine learning. So first you have a training phase and then you have a use phase. So in the training phase, we could make use of a RAN emulator. So according to Diego's comment, it's an emulator. So you need to generate traffic, right? You could retrieve data from a real network, but what you want is that the model behaves also according to the real implementation in critical situations. So typically you don't have critical situations in a real network deployment unless you really are close to failures, right? So with an emulator, you could stress the models into a situation where it may be risky to continue and you need to scale either CPU resources or whatever. So there are different ways to do that. And so if you have a model where you put operational sequences as input and get CPU utilization, memory utilization, any kind of parameter as an output that allows you to assess the situation, if it's critical or not, that can help a lot. So in the draft, we refer to one machine learning model that we leverage for some mobility scenarios. It's based on a recurrent neural network with long short-term memory. It has very good prediction characteristics. It's one of plenty of models that can be used. Also, people start playing with transformers, which is the fundamental model of large language models. But they are very good not only in text processing or generation, but also vision transformers exist. So there are plenty of new models, and it's a really fast-moving target. So models, they grow like crazy, and it's really the point of research to pick the right model to meet your needs. So that's a little bit what we discuss in the draft. It's not as much updated as we had in mind, but this is work in progress. And that brings me to the last slide. So what are the key messages here? There are probably more, but NDTs gain more traction, right? And they can be used to support testing, failure prediction, avoidance, whatever. R&D and expertise on AI, Gen AI models and the applicability grows in the community, and we can see more and more research papers in this area. We also hear more and more about in-house hands-on experience, and that's exactly what we want to reach with that draft, and take the NMRG or other platforms, but come together, share your experience about your practical hands-on experiments in the lab, and this helps probably the community to do better work in the future on this complex topic. So that's it. Let's share use cases, models, pros, cons, good and bad experiences, and start today. Thank you.
We have people in the queue.
Thank you, Marco. This is Jan Porjong from SKKU. Let's go back a previous slide. So you have some architecture, 5G mobile network data twin. So you are using a LAN emulator, or so in the middle you have the core network. So I'm wondering, the 5G network, radio access network, and core network is we have many, network function like the PCF, UPF, SMF, MF, something like that. So a complicated system. So I'm wondering, so are you using some open source for emulator, or you're making your own emulator for 5G network? So that is my question. So
you mean our?
Yeah.
So the question is about our in-house experiments.
Yeah,
not
yeah.
the general
The emulator, how to make a radio access network and also core network, how to emulate?
Well, in
Yeah.
our case, we have access to both. So whatever is needed. Open source is very good. Proprietary development is better in some cases. The point here is that you really need to generate traffic to stress the model and make it learning from the actual core behavior to react on this volume of traffic. So not all open source emulators meet these requirements. They have limitations. You may touch that source code to meet your requirements, but I think you need to see what you, in the end, want to do with the twin. And then you need to decide what you need to really set up the system under test and the emulator to train your machine.
Okay. So another question is, you can see, are you also consider the UE mobility scenario like, so later access network case also the user equipment, right? We consider some beamforming and the phasing, many things that considered. So are you consider those realistic setting?
In our current in-house experiments and research, no, because the focus is on different aspects. Beamforming is a RAN particular aspect. And if you want to do that, maybe you can make use of realistic models of a radio access network, maybe based on ORAN.
Okay.
But beam steering, these kind of things, we don't look at. Okay. No. So we did some network twinning on radio a while ago, but with a different focus in mind. Now we want to move a little bit more to the core network.
Looks like you guys, your group focus on some core network, right? Later than later.
In this work, yes. We had other work where we focus more on the RAN, but we don't present that here.
Okay, I see. Okay, thank you, Marco. Yeah,
sure.
Thank you for the talk. I have a question because your goal also is just to stress test your system by generating traffic and with the RAN emulator, if I understand well. And then you use basically the digital twin to see how it will react, right?
Well, it will react according to the standards.
Yeah.
And it will take this amount of resources from the CPU. So you can see limits. And that's why I said it really depends on how you deploy it, right? If you pin CPU resources to that particular container, or if you share resources. So based on your deployment, you may take the twin's output as a ground source to decide if it's a critical situation or not. Maybe with prediction, you see.
Okay, so
look into the future.
Yeah, so I think I understood well. So maybe it's more a question. So you assume that somehow you know a bit the situation you want to end up, because you know, for example, in the left part of your figure that you want to generate this type of traffic because you assume that it will stress test, so you increase memory usage, CPU usage. Do you think that we could not use the digital twin in the other way, that by changing some parameters, for example, for your emulation, you see how it reacts, and maybe this is a good way maybe to continue to maybe investigate this case, for example, of type of traffic that I did not, let's say, expect to stress test the system. You see the other way around? I don't know if you see what I mean.
So typically you have session states in the 5G core, and you don't stress a network function or group of network functions with their resources if you just have the mobile connected and not communicating, no handover, whatever. What stresses the network functions is bulk registrations or bulk handover. So when you generate traffic that you move these network functions into transaction states, right? So processing these messages, and not only 1 per second, but maybe 10,000 per second, you really stress the resources below, right? Where you may have limits and then see if there is a reason for failure or not. So currently we look at particular sequences that we feed into the twin to see where are the limits and how can we make this group of network functions being modeled in a way to mimic a realistic network. But in the end, the realistic network has plenty of other session states stored, right? So you may have another subgroup of mobiles doing handover. So this is currently taken out.
I was wondering about the sequences because you can also play with that, I think.
Yes, I mean, if you have an emulator, you're free on which sequences you choose. If it's downstream paging, if it's upstream registrations, if it's upstream handover. So as I answered to Paul's question, it's currently we don't look into handover or RAN aspect, but start looking mainly at a particular type of operational sequence and see how the twin behaves and if we can train it that way.
Okay, good. Thank you.
Sure.
We have Cheng next, please.
Thank you for sharing. A question here. I read your document and you list some general challenges in for a network digital twin, and you also list several cases. And I want to know whether there are any case-specific challenges that are different from the general challenges, and where you can add a map between each cases and the challenges. Like you mentioned the SDN, quantum, and 5G. Their real-time requirement may be different. Their latency requirement may be different. So like this, thank you.
If I get your question right, if not, then please correct me. But that's why we presented 3 cases now, and they have very different characteristics: fixed network, mobile network, quantum key distribution. Also, the planned use of the twin is different in the 3 cases, which means you really investigate different methodologies to build a twin. Not all of them are based on machine learning, right? So simulation or building a software copy of your real network, that also suits a network twin. So this is what we want to investigate. And AI is not the solution for everything, like IPsec was 10 years ago for IETF to tackle all security issues, right? So I think you really need to tailor the model for your twin based on its need, right? And so the map you're talking about, you are requesting a map to compare the particular challenges of the different use cases. We can do that, yes. But maybe that map can be generated with help of the community. That's why we want to have your feedback and maybe discussion on the NMRG Explorer.
Okay, thank you. Thank you.
Thank you.
Hi, Marco Rashmith from Huawei, Canada. So the model that you're putting together for the core, so how extensible is it? Can we actually, how much work would it take to actually take this model from operator to operator? Or do they have to actually do a lot of work to actually fine tune it to the, or can we come up with a base model that actually works somewhere? And then the operators can pick up that base model and maybe retrain it according to their network topologies and functions and everything else.
So building such a model in the view of compatibility with production networks of various deployment sites, that's not something we currently look at. So we first look at the fundamental challenges in doing, finding the right models and ways to train these models to get realistic behavior in real time. Compatibility, comes next. Of course, it's wishful thinking that you build one model and then you do minor tweaks to make it accurately behaving compared to this deployment or that. But as I said before, most of that is software in the meantime. So it really depends, the behavior of these network functions depend a lot on your deployment, right? So I'm pretty sure different, let's not call it operators, I mean, there are private 5G sites, whatever. It depends a lot on how you deploy that, right? And that depends on how you want to make use of 5G, right? How much traffic can you expect? How many instances you need? So a real 5G network is more complex. So you have load balancers, you have scaling mechanisms, these kind of things. So we progress on that work, but not yet in the view of building something that can be widely deployed.
Thanks. I'm
If
just-
that answers the question.
Yeah. It's fair. Like, you know, I'm just curious to see like how much is this going to be an individual exercise as we go from operator to operator, or can we actually can we foresee something that as a base that can be later on be used by different operators?
Maybe you really need to do the training based on a particular deployment's characteristics.
Yeah,
So you need to train a model based on each of these deployments. Maybe not. That's a question to answer. But I see there is a lot of interest in 5G network twins. So maybe also the others are some of interest, but many people here are aware of 5G, maybe 6G in the future. So that's the starting point.
Thanks.
Sure.
Thank you, Marco. Thank you for the comments online, and an interesting discussion, I think, to follow on the list or in the corridor. Next will be Reza on behalf of the author for a new work that is proposed in different working group and research group.
Thank you very much. Hello, everyone. My name is Reza Rukui from Siena. On behalf of the co-authors and contributor, I'm going to go through what is AI for network operations, what problem we try to address, what are the potential challenges, and what are the opportunities. This presentation is rather more question than answer. This is a new topic, especially about AI, AI ops, Gen AI. You've seen the old presentation. They have that one somewhere in the title. So the whole idea here is this is a new buzzword. From the IETF perspective, what it means, or from this draft perspective, what exactly it means, and what are the opportunities that we can bring from the IETF and IRTF. And to address that question, maybe the answer is in a spectrum of doing nothing, meaning there is no relationship between this one and IETF and IRTF, and there's another side of a spectrum, there are lots of things that can be done. So the whole purpose of this presentation is to bring the awareness that this is a topic. Let's think about it. What are the artifacts that we already have as an ecosystem on IETF and IRTF that we can leverage and use here? And this is the whole idea of first awareness, and second, think about it, what are the areas that we can do. And the last but not least, I will touch on the idea of AI ops and network digital twin. I was glad to saw that the first presentation talk about that one up to a certain extent, and we have some discussion with Jerome and Laurent yesterday as well, so I will touch on that one as well. So the idea of the presentation here is for the first few slides, I go through the definition of what exactly it means. It's a terminology that if you are not clear exactly the definition, the consequence discussion, it seems a bit irrelevant. So to that one, when we talk about AI, there are three aspects, starting from the left-hand side. Network for AI. It means that how to design a network to accommodate the AI type of traffic, anything that you see about how to design a network. Do I need to create any special configuration on the data center? Do I need to do the bandwidth management, bandwidth on demand? All the aspect about the network itself is the first category. The second category, AI for networks. I have a network, is designed somehow. Is this for us an opportunity to take various type of the AI, ML, generative AI, and so forth to use in that network? Can I use some kind of the optimization, assurance, predictive analysis, reactive assurance, proactive assurance, automation, any type of action that we can do on the network. And this is the second one. And by the way, this is AI NetOps, that the middle one, AI for network. And last but not least, just for the completeness of a discussion, very last one, AI for engineering. Generally, the idea of using AI in an enterprise internally, using the Copilot, the GitHub. These days, any application has some level of the AI attached to it. So, long story short, the middle one is what we want to design or talk about. I have a network. Is there any way that I can use that network and to use it in the context of the, and why it is, all of a sudden is very important, and everybody talks about it. AI and ML is not new in networking. For last at least 10, 15 years, everybody was talking about it. I put 3 reasons why these days is important. Might be more reasons, but these are the 3, the obvious one. The very first one is ChatGPT, Gemini, the Google, the Gemini and the Llama, and everybody expecting some level of the generative AI. This is the first one. Because of that surge, proliferation of this type of ecosystem is important. The second one, which is very important, willingness of the operators. As you see, AI Ops. Ops stands for operation. So operators right now have the willingness to work with vendors collaterally to say, yeah, let's do something together. If I asked an operator 5 years ago that I want to do something, they question, why you need access to my network, why you need access to the data that I have, and lots of reasons they didn't want to do it with valid reasons. But this is another important, very important aspect. And last but not least, the very low cost of the software and hardware that I guess obvious. So get back to the definition. Again, definition is very important. If we talk about something and we have different mindset about that thing, the discussion, it seems irrelevant. So here, when we talk about the AI for networking, from the left-hand side, I have a source of big data from the network. That network could be any type of network, at least for our application, is either IP network, optical network, or multi-layer IP or DWDM. It could be anything else, if you want to use it, but in the context of the networking, this is a source of data. It could be historical data that I'm collecting from the network for last n number of days, and also the streaming, real-time data, telemetry data. In this one could be time series that I'm collecting from the network, PM, alarm, topology, logs, OEM data, and so on and so forth. That source of the data goes to an engine, AI NetOp. There is a typo here. There should be AI NetOp, that circle. It makes sense of that data, create relationship, make an insight of those data, and based on that, it can go make an intelligent decision. What are those decisions? We will talk on that one in next 5 minutes or so. And eventually, it make a decision that, okay, I have to do some remedial action or actions, depends on the use case, and potentially we can automate that process. The whole idea of this process, putting these together, come up with the operational benefits. Now you will see that AI NetOps. Ops is operation, AI various, and network. So you will see how everything works together. And those use cases that we are talking and we group them together is in the area of the assurance, optimization, and automation. The rest of the presentation and the rest of that draft basically is elaborating on that box on the right-hand side. What are those optimization use case or scenarios? What are the automation one? What are the assurance? And how relevant they are? The important aspect that we put this document together is not just random use cases here or there. We just list a linear list of every use cases. We have a context in mind that they are relevant, and these are the 3 contexts that we are referring. So Some of them I put background info. I assume you already know that. If the answer is no, this is just to refresh our memory. When we talk about AI, is the biggest bubble. And this is the reason in most cases talking about the AI is irrelevant, because AI is very generic concept. As you narrow it down, we use some level of algorithm to create it's machine learning. You use a neural network because deep learning, and if it is related to LLM and generative AI. So I put it here just a context when we talk about generative AI, at least have the mental image what it means. So same thing for generative AI. I skipped that one. That I assume you already know that. If not the case, reach out after the meeting. We can talk about it. So coming back, now I have the very clear definition. If somebody asks why is AI NetOps from the perspective of this draft, the first few slides is describing that there is no confusion. 3 use cases, 3 group of use cases, not 3 use cases, 3 category of use cases. I say this one over and over because it's important to have a context for the whatever we propose in the draft. Now, each of these category, we define group of use cases, scenarios. The intention of this one is not just go through that. I assume you already read the draft or you are going to do it. But the idea here is a group of assurance related. It could be starting from the cognitive search at the top, going through the reactive, proactive assurance or predictive analysis. All those have a flavor of assurance in mind. And there could be more use cases as we go through that. We want to bring this awareness. If you have any use cases that is in this category and we don't have it here, the first attempt was to put everything there. We can narrow it down, we can prune it later on, but it is important to have everything at the beginning. Same thing for the optimization. Some level of the IP optical planning, optimization, traffic optimization. You can read it, it's self-explanatory in most cases. And last but not least, for the automation. I want to do some level of automation. Some of these use cases we can argue is automation or assurance. It's not the point. The point here is we try to, as a holistically give a context to the use cases instead of randomly having 100 use cases that there are no correlation. Because if I talk about predictive analysis, for example, and predictive AI, there is a good chance that there is a core of functionality that I can develop and use it in that context. So this is the process behind whatever we put here. So one of the important aspects of lots of these use cases rely on the context of the dynamic workflow, agentic-based, multi-agent. I put it here as an enabler. This one by itself is not a use case. It's just a tool use case that we can use this tool to implement lots of the scenario that we mentioned. For example, I want to do the predictive assurance. I need some level of the trending and forecasting, using that one in the context of some level of the dynamicity of the network to do something for me. If something happened to the network, we want to do it. So this is just a framework. It's an enabler for that. If you are not familiar with that, this is something that's relatively less known. When we talk about generative AI, everybody knows about ChatGPT. They can go and create text and image and those things. But this is one of the functionality that is well-known. Generative AI, if you don't know or if you are interested to know more, the generative AI has a context of the reasoning and acting. It's very similar to the human brain that when I want to answer a question, I just go through, think about something, realize that's the mind, get the result back. I go to a loop. Whatever result comes, I go and refine my thought process. And this is the best tool from the networking perspective to create that dynamicity of workflow. If you are interested, again, you can reach out, we can go through it. But keep in mind, just Google it or use the ChatGPT and find what React framework is, reasoning and acting, how multi-agent is going to realize that, and how that one is going to use in the context of dynamic workflow. So it's a very strong proposition and framework which allows us to realize lots of use cases. So putting all this together, I started from very high level, define what AI NetOps is, narrow it down to 3 groups of use cases: assurance, optimization, automation. And I went through at the very last point that I talk about enabler. I'm putting all this together. This is the draft that you will see. The attempt of this draft is to define the problem, and at the end, is there any relevance to IETF or RTF? We don't have the answer. We started this one maybe 2-3 months ago. Last IETF, we sat together with a group of people. They said, seems that we want to do it, and we basically produced that one. So when you read this one, most likely you have more question than answer, which is good. This is the intention that we want to bring. You ask more intelligent question about that. And the whole idea of this draft is to go through some of these questions to see whether or not it's relevant to NMRG. The answer might be no, it has nothing to do with NMRG and research aspect. We have to go somewhere else. But we already presented this one at the routing group. We wanted to do it for operation. They didn't have a slot to do it. We had a side meeting, and this is the last one. So our thought about the question, this is some of the area that we think we can do it together. There is a relevance to NMRG, but again, we can discuss it. The whole idea here is that we have the question, but not rather answer. The first one is bring those 3 draft to see how it's relevant. I should admit that I didn't read them. Daniel put them, and we have to see how they are relevant to whatever we do. The second one is continuation of whatever the first draft for a network digital twin talks about. And this is, again, less known. I'm sure if you go and talk about the AI ops and AI net ops, the same terminology, the same thing. Some of the people might ask, how is it relevant to digital twin? How these 2 work together? What does it mean? Exactly, they work together. And this is the whole idea of the second item. We had a meeting, a very good meeting with Lauren and Jerome yesterday. If you are interested, we want to put this one as a work item inside this draft or potentially a new draft. So if you are interested to be part of that number 2, that you want to do something together to bring digital twin and AI NetOps together. What it means, we have some thought on that one. Some of the creation of the simulated data, those things is a portion of that. But the vision that we have is bigger than that. So this is potentially the second item. And the third item is about that context of the generative AI that we mentioned, the multi-agent, and the whole idea, if you go through the detail that we put in the draft and we have to complete it, there is a relationship between these agents. There is a definition of the agent, how they are interacting to each other, how we are defining it. All these are potentially could be a work item that we can do at IETF. If there is an agent, how we are describing the capability of this one. If 2 agents want to talk to each other, do they use a natural language or API? Do they use a standard protocol, or it doesn't matter, any protocol? All these are important aspects to address. This is number 3, which LLM to use, how to use it, everything around that enabler. And last but not least, it's something that how we can use the IETF protocols in that context for some of these use cases. For some, the answer might be, doesn't matter, but for some, it might be important. So with that one, I can conclude the presentation. Again, the idea was you have more question than answer. I hope I reached to that level that you have some question that you can ask, and the stage is open for questions.
Please go back one slide because I think it's nice to see this. Okay. We have Xin.
And this is Xin from CAICT. And thanks very much for this work. I think the scenarios in the draft are very useful. And my question is, you raised the discussions in this slide and about the question 3. Actually, I have proposed a draft on the network management agent in NMOB. So my question is maybe you can take a look at that draft and we can see if the content in that draft can solve the problem list on the question 3. And we can talk about how to cooperate to do the work on agents.
Sure, but I also ask you, do you read our draft to see how we can work together? So I will read your draft, you do the same thing, and let's have a talk before, after. Send me a text, send me an email,
Okay,
and
no problem.
give me the draft number. And it's great that there is something that you already did something.
Yeah.
Great, yes, this might be something. And you can, by the way, join our draft as a contributor. If you're interested, you can do that one. And by all means, this is a good, this will be a good collaboration.
Yeah, I mean, you can also join my draft to
Sure, we'll
do some input.
Yeah, definitely. I will take a look. Yeah.
Thank you.
Yeah, collaboration. More questions?
Yeah, we have Pedro online.
Okay, can you hear me? Sorry, can you hear me?
We cannot hear you yet, Pedro. We cannot hear you, Pedro. Can try again. Okay, just for the sake of time, Pedro shared also the question in the chat and in the notes. I'll suggest to move on to the next people in the queue, and if we manage to hear Pedro, we can take it later. So we have Takuya, please.
Takemasa from KDDI. So I have one clarification question for the scope of this draft.
Can you speak up, please?
How about this? Good. Okay. Takemasa from KDDI. So I would like to clarify the scope of this work. To me, it seems to talking about only for the inference part. I think how to use AI model for the network operation. But how about the training part? How to train the accurate network model for the network operation? I think this kind of the work is also challenging.
Yeah. So good question. This is one of the, I can call it, misconception that when we talk about AI ops, everybody assumes that there is a model that we are going to take and train it. So this might be the first impression for whoever look at it. For some of the use cases, you're absolutely right. If I want to do, for example, predictive analysis, predictive AI, I want to do trending or forecasting of something, that something could be a KPI of the network. Now I call it, quote unquote, non-generative AI, meaning traditional or classical AI. I take a model, train it with the data that I have to do the prediction and the forecasting and do something. So the assumption that you made that I need that for all the time is not accurate, because depends on the use case. If my use case is the reactive assurance, I don't need to do any training and forecasting. But if there is, definitely for some of these use cases, and you will see in the draft, there is a flavor of generative AI and non-generative AI, or both. So the example that you gave, you assumed one of those use cases has the characteristic of both. If this is the case, definitely the model that I use, they are orthogonal, by the way. I'm doing the training on something and use that one in the context of the AI NetOps. They are related, at the same time they are independent. Valid question, depends on the use cases.
Yeah, I agree. Thank you.
Let's try to have Pedro again.
Sorry, can you hear me now? No,
I cannot hear you, Pedro.
Yeah, sorry, I am trying.
Go ahead.
Hi, Scott Mansfield Erickson. Just a couple questions about what has been done to look outside of the IETF for work that's already happening in this area. the ITUT has a recommendation already on the AI enhanced telecom operations with AI. So there's work like that. There's also a focus group on AI for native networks, and there's also a Plug Fest this July called the AI Readiness Plug Fest. I was just wondering if you were aware of any of that, if that would help with any of this work, and if your terminology was aligned with the other industry.
Okay, yeah, thanks for bringing that one up. I was, not to the extent that you just said that. If you don't mind, just send a list of those things to the chat or
I will do that.
to send to
Thank
us.
you.
But answer as a general question, since I didn't read it, I cannot give the concrete answer to that one. In most cases, is the whatever they want to address is basically they are assuming that there is a black box to do some functionality and they want to use it in the context of the bigger ecosystem. But the context that at least I see here, if I want to build those building blocks, how I can do it, what is relevant to the communication, mainly from the IETF perspective. Is there any way that I have to standardize the communication between elements, or doesn't matter? Maybe the answer is either or. Maybe the answer is doesn't matter. That is by itself is important. But one thing as a general rule that I forgot to mention at the beginning, since you brought that one up. When we talk about, as a general rule, IETF, this is the way that I see it. We want to do something that is used by the operators. This is the ultimate goal for us. Whatever artifact that we are producing is going to be consumed by operators. And this is one of those things, maybe at the very end is really nothing to implement as a new concept, any protocol, anything in that context, but we can use all the artifacts that CCAM, TEAS, NET, all those generated in the context of use case. That one by itself, to me, is very important and very valuable. So take that one in the context, be open-minded about all these things. I think it's very important to see it from that angle. One angle is maybe I have to implement new feature capability. Other angle is there is nearly nothing to be create new, but use everything that IETF already has, lots of in the artifact in the context of those use cases. Both of them are important, and both of them are valuable.
Thanks. Thanks for the extensive answer. We have also people in the queue. We are a bit late on the agenda, so I mean, just a feedback with Scott. You can mention that if you want to give feedback now. Just
no, but just very quickly, I appreciate everything that was said, and if you look at the ITU work, it does have a tendency to be architectures and frameworks and look things for top down, where the IETF work has a bunch of pieces that we're trying to figure out how to put the pieces together to build. And at some point you end up meeting in the middle, right? So I just wanted to make sure that there was awareness. There's been liaisons back and forth. There's some published work. So I'll put some links in the chat just so that we can make sure. And if there's anything like this presentation, would be awesome to send back as a liaison response to the ITU as well when it gets a little more mature. Thank you.
Yeah, thanks. That's appreciated. I think this awareness of external work and having, state-of-the-art review could be very useful to situate on both sides.
You're the last one I asked you.
No, let's try to just give again the floor to Pedro because he has been in the queue. Pedro, can you try to raise your question?
Yes, can you hear me?
Yes.
Yes, I okay. My question was quite straightforward. It is that you talked about current AI, and today we all know that the most common machines that are in running AI are LLMs. But have you considered other kind of practical machines that or models, no, that physical or virtual models that move other kind of AI? What I mean is that we know algorithms, we know neural networks, we know whatever, but okay. But currently, the models we have are only for language. Have you considered other models, big models? I mean, 10 gigabyte model or whatever, but
I have to admit that I just get maybe 50% of the question. If just rephrase the question, it might not be that. It's what's talking about the, can you just
rephrase? Yes. The also question is what other practical models or even physical machines you are considering for this AI for network operations?
Okay, so we didn't go that far that which model to use and all this. You will see one of the item here is talk about that depends on the use case. So we have to talk about the use case. You tell me the use case, I will tell you which one and the machine and all those things. So you cannot overgeneralize that. This I think it's better to put on the mailing list if there is any specific question that you have for a specific use case.
Okay. Let's discuss later in the mailing list. Thank you.
Yeah, no problem.
Thank you, Pedro. Dan?
Yeah, so very quickly, another comment for Pedro is that maybe with some of the use cases, we can have an input from a sort of non-typical network model. It may be weather, it may be human crowd modeling, it may be the train times and the level of disruptions that are occurring in a particular network that might affect the number of people accessing particular wireless access points. So we're always sort of open to other inputs. The document has 20 plus use cases. Now I mean, obviously that's a huge amount. And several of those use cases are really cookbooks about how you combine the IETF technologies, so protocols, data models, sort of network APIs, service APIs, etc., to augment your potentially network digital twin, some other OSS system, and then how the AI is embedded. So we've got a combination of both engineering as well as sort of longer term research, maybe some of the enabling or sort of more recent AI techniques. And what we're trying to do by coming to the NMRG is saying, what are those kind of research challenges that may actually feed into some of the engineering challenges in the future?
Yeah, okay, thank you for clarification. And last, Laura?
Yeah, so with Jerome as chairs, so thanks for bringing this work to NMRG. I think you also, as you said, presented it into other groups in IETF. So it generates interesting comments. I think the key thing to situate will be to differentiate in this proposal what will be more to the IETF, to the interest of the IETF, and what will be more to the interest of NMRG or IETF from a research perspective. I see a bit of a challenge. I mean, the draft is interesting, but if you have a large number of use cases, I'm not sure how it will be tractable to separate between going to present IETF things and NMRG, I mean, research things. So a suggestion will be to kind of extract specific elements of research, research questions, challenges, or unaddressed, I mean, unsolved problem that you can pinpoint to, okay, it's illustrated in this use case, or it's this facet of the work, but to make something clearly, I mean, articulated towards the research work that could be done. More on a personal level, I see kind of an interesting venue could be on the impact of agent frameworks to network operation. I think this is an interesting angle that can generate changes in how we approach management architectures and operations, but this is just a personal opinion. So I will say we really need to see how you are going to articulate this broad work into the NMRG context if we want to be able to continue to move it practically, I would say.
Yeah, thank you for the insight. And we try to see if it is possible to break it down into the personality that you just mentioned, which logically makes sense, but practically we want to see if it's possible. And at the end, if there's anything else, mailing list or reach out to either of the co-authors, we can continue with that. Thank you very much.
So we have two remaining presentations. The next one will be by Chui.
Yes, can you hear me?
Yeah, we can hear you well.
Oh, okay. Thank you, Chairs. Hi, I'm Chui from China Mobile. Today, I will give the presentation of large model-based agents for network operation and maintenance. So here, I first want to thank you, Rocky, for giving the big picture of the AI perspective background and also agents. So I think today my presentation may answer parts of your questions in the final. Okay, please go to next page.
You have the control of the slide normally.
Oh, okay. Thank you. Okay. So the aim why I want to start this item is towards the goal of achieving autonomous network level 4 to level 5. Operators choose agent solution to improve network automation and intelligence. Agent can autonomously perceiving its environment, making decisions, and executing actions. It demonstrates learning and decision-making capabilities where algorithms and data analysis allow it to extract valuable information from massive data sets to build its own knowledge base. During decision-making process, the agent considers multiple factors and employs method that's logical reasoning and probabilistic statistics to formulate optimal decisions. But agent is more robotic. It aims to understand the human's intent and better understand the network information. Then it can serve as what we wish. Agents can achieve a closed-loop operation in specific tasks, replacing manual human execution. In order to allow them to handle matters like humans, the first critical challenge lies in defining what data they need to understand, specifically what information is required to complete these tasks, and how different data elements should be interpreted. The second key issue involves data transmission and transformation. Since agents cannot directly comprehend the raw network data, and given the different APIs they need to access require varying data formats, it is necessary to explore potential standardization of interfaces and assisting the impacts for the communication protocols. So for this project, I want to include three parts. It will start with the investigated application cases in the network operation and maintenance. Then research the technical and the functional architecture of network agents, develop a unified function framework that adopted to various network scenarios. Finally, define requirements of data, interference protocols, and etc. during the interaction between agents and networks, identifying impacts for both sides to ensure the seamless collaboration. I will provide examples to explain in detail in the following slides. So before going to a specific case, I will introduce the architecture of large model-based agents first. An agent can receive users' requests directly. It has the capability of perception, planning, memory, action. Agent usually starts its job when there has users request to or task requests from other systems. Besides, it can also proactively receive alarms, threshold exceeding notifications, or environmental change information as a trigger. This part potentially involves multi-mode data processing. The intent recognition understands and interprets user input intentions, determine whether the subsequent tasks require identifying suitable agents or a multi-turn diagonals to complete intent recognition. Intent classification and analysis decompose tasks based on recognized user intent. Categorize tasks according to different functional requirements. Planning is to analysis and decompose intent based on task objectives and learned knowledge, and also spelled complex problems into simple ones, and identifying required system components, for example, other agents, large models, APIs, and etc. The memory has long-term memory and short-term memory. The long-term memory usually stores user hobbies, domain-specific processing experience, for example, the failed or success cases, or encountered faults, etc. in the knowledge base. The short-term memory caches temperature processing data like the context, and the agents will search memory to help to do the planning. Decision-making finalize execution plans and match workflows to current tasks. In the action phase, agent will convert orchestrated results into the network understandable commands and call the network API or system to finish the operation. Okay, also back to this pages, for supporting the interaction between agents and network, the network system and the platforms, even the current AI models or autonomic capabilities, several tools, or for example, the LAM data can be fed to the agents. So all the network system can have the good collaboration with the current robotic agents. So the next page actually is what I'm trying to explain in the picture. And I will directly go to the final page of my slides. So here I list a very specific case for the network migration operations in the network as example. So when we do the route advertisement for updating and publish routing information, the traditional way is the operator will start to do this thing and make the plan with the configurations of network elements. Then the configuration will be verified, for example, giving the configuration for the NDT and let the NDT to say if this configuration have any problems. If the configuration has passed, then the system will do the configuration distribution. During the whole process, the system keep monitoring, for the example, if there have any faults or any warning here. And after that, the whole process has been ended. The whole process is actually the manually, so the people control every process to finish the whole process. And during this part, the people may doing many repeated actions for finish the whole task. For example, he had to check the system many times to see the status. But for the agent way, so it first maybe start from user requests that described in natural language, and the agent, when agent receives this part, it will first do the intent recognition. It should be identify the user's objective, the data needed to finish the task. Then after that, it understands what the task is going to achieve. It will do the planning. Maybe it first maybe start from research the memory to see what the before a example or the experiences are. According to them, it will do the planning and it will see, okay, there may close 4 steps. The first step is make plan. Second step is doing the verification. Third step is doing the configure distribution, and also is doing keep monitoring. And in the verification part, the agents will keep output the configuration and then reflect if this is the right thing. And during the multiple interaction also with the user, it will finally giving the right configuration, like what the people can do. If this is right, if this is correct, then it will directly call the NDT to do the verification and receive the results. Then call the corresponding systems or APIs to do that. So, so for this case, there has 2 parts to do. The first one is what kinds of network data should be sent to the agent to understand what he's doing for the next. And finally is because there has different API and with different formats. So in order to let the agent to understand, there may have the impact on protocols, like to have unify the protocol or unify the formats. Okay, so I've just stopped there. Thank you.
Thank you. Yeah, two comments from my side. The first one is I think in what you presented and also in the document you mentioned different functions or functionalities of the agent. There are plenty, and one good thing I think if you for continuation of this work would be to identify for each of these functions what are the let's say major difficulty or challenges to address, and because I think we have maybe somewhere we have to see where are the most, let's say, research which is needed for make it happen. I think we can think LLM can solve a lot of different functions in your with expectation. You can solve from the beginning to the end, from the user request interpretation to generating low-level commands. And of course, if you also look in the state of the art, you can see a lot of papers probably are working on specific part on that. And I think it would be good to identify what are the main challenge for each of these parts, and also what are the different, let's say, state of the art papers that are working on these specific parts, and to try to see a bit kind of identify what is the most blocking point into this. That should maybe help to somehow frame the work. Second comment, and I will let you answer. But I think it could be good also maybe to make the connection with the previous presentation and ANET Ops document, because there's probably some use cases that are described in this document that can relate to what you have described there. So I think it can make also a good connection and help also to the other author of the other document to identify what are the research part, and that will help both of this.
Okay, thank you, Chair. And actually, for this part is you know that the agent that actually can be used in different kinds of process, but from the network operation and maintenance part, it's more like, you know, for the workflow or the architecture part, they may have similar, but the real question or research key points is that the agent is more digital. It not understand the many you know what the API notification represents. For example, when there has a new equipment or router coming to the network, the people know it has to, maybe the next station is we update the router information, but this thing is need to be summarized to let the agent know what kinds of data that represents the action I'm going to do. And different cases may have different data or different characteristics. And then the agents, what it consumed for data is, for example, the natural language or photos or the other structured or unstructured data. But the network's data is not directly matches the data format, and actually the network has different formats of data. So in order to finish the whole automatic way, I think there has the connection requirements, or even we may need to have a unified protocol to help the agents to understand, and also the agents needs to have a bridge to really operate the network to finally finish all the operations. Thank you.
Thank you. Just a quick feedback on this. And yeah, I think you mentioned a good point regarding the data, and this is a part that also is, I think, really relevant to the group, as we discussed already. And as we articulate also in the AI challenge documents when coupling artificial intelligence, not only especially Gen AI with the network management, that there is a mismatch between the data that we usually used in networking and the data that are usually used as input as to the, let's say, AI in general. So good point, thanks.
Thank you.
Next question from Mingxi.
Hi, Chui. I'm Minzhe Xing from Beijing Zhonghua Laboratory. My question is, do you have some implementations on large language model-based agents or multi-agents for solving some specific networking tasks? And if there were some implementations and maybe some experiments conducted on the implementations, what's your observation? Thank you. That's my question.
Okay, thank you for the question. From my constant observation, in the network, there has the scenario of multi-agents collaboration. For example, in the fault cases, that the one agent can do the recognition agent, for example, receiving the alarm and recognize this is a problem, but it cannot positioning what is the problem finally are. So it may call, for example, the specific domain agents, which is more professional for those questions together, and then the upper agents may make the decision based on the different. For example, the core network agents, the run network agents, or the transport agents. Between those four roles, there must have some communications. And maybe between different roles, they have different languages. For example, maybe the run have its logic, the core network has its logic, and also the upper agents have its own logic. And so actually mapping into this part, it may be different practicals or the different key features. And I think between those parts, we can do something to really like the different agents to understand each other. And that's where we can do maybe the standardization or practical works.
Oh, okay, thank you.
It's me, right? No, just a comment on this. On what when talking about agents, I believe that's something that is extremely important, probably the most important thing that we should have to consider, and I don't see it in this diagram, is the possibility that agents collaborate among them. I mean, because that's the very nature of agents, because that's a diagram like this is basically very similar to an intent translator that we may have discussed in the past. You get some high-level language, natural or not, then you make an assessment of feasibility and you implement it. I believe that the real challenge here is about the collaboration among agents for for achieving collective goals, and that precisely the challenging, the research challenge here is about how we define and how we set the interfaces among agents.
Thanks. I think you have good points, and I also agree with part of that.
Thank you for the presentation and the comments. I think we see that some touch points emerges on this notion of using Gen AI and different agent frameworks for network operation. The last talk of today will be given by Mengxi.
Okay, hello everyone. I'm Minzhe Xing from Beijing Zhongyang Laboratory. The topic I'd like to share is about using a large language model to assist network management while keeping a human operator in the loop. Okay, let's start. The traditional network management faces some challenges, including complex and diverse network environments, and users are also will express some diverse intents and demands, and the rapid evolution speed of the network, and the difficulty on learning some vendor-specific device operations. There are some discussions on the vision of autonomous network management in Terraform, and they propose the requirements and features of the autonomous network management, including zero function and self-function. They also propose the level definition of the degree of network automation. Maybe we are currently in level 2 and are transiting to the level 3, which is a hybrid manner of the people decision and system decision. The large language model has shown its great success on solving some tasks and demonstrating its multimodality data understanding, logical reasoning, and generalization abilities. The large language model provides a promising direction for the network automation. For example, we can use a large language model to generate some device configurations based on the user's natural language input. This area also has attracted increasing attention of researchers, and they have published many papers on top-tier conferences and journals in last year. So the key point we want to focus in this study is that the human should still in the loop. This is based on two consensus in NMRG charter. The first is that it will be a long-term process to replace the human operator by some more intelligent mechanism. Second, it's also important to give a clear definition of the interfaces between human and the self-driving system. So in this, as we will introduce the proposed large language model assisting network management framework with human in the loop. First, we will introduce the framework components that build the intelligent system and the workflow of the autonomous network system's decision and the human in the loop. And the mutual interface between human operator and large language model assisted system. This is our overview of our framework. It consists of three major components. The enhanced telemetry module is responsible for improving the semantics of the raw data collected from the network devices, and the large language model decision module will generate the configuration for specific network tasks. And the human operator will audit the generated configuration passed by the validation module and the access control module. Okay, next we will introduce this module in detail. The motivation behind the enhanced telemetry module is that the telemetry module, for example, in XML formats, often links some field description and structural metadata For example, as we can see in the middle figure, the raw data may lack some necessary field descriptions. This could lead to misinterpretation or erroneous reasoning, as the pre-trained large language model may lack this kind of contextual knowledge. So we propose to inject some unnecessary information into the raw data. For example, in the right figure, we can extract the test description from the young model and inject this test description into the raw data and to help the large language model decision module understand the network situation. In the large language model decision model, an important component is the retrieval augmented generation model. The RAG is a very commonly used approach in large language model to enhance its external knowledge. And the external knowledge can originate from some data sources, including the device documentations, expert knowledge, and young models. And we can retrieve the relevant knowledge from the RAG database by calculating the text or vector similarities. The next model is a test instance management model. The operator should first specify a task, for example, task traffic analysis or optimizing or attack mitigation. The task instance management model will generate a task instance which consists of 3 basic elements. First, the operator should first select the foundation model and define the task description, input and output format in the prompt. And they can optionally use fine-tuned weight trained on private data sets. As we know that the large language model's output is uncontrollable and untrusted, so we need to control its access. So we refer to the RFC 8341, the network configuration access control model. It consists of 4 major concepts: user and group, access, operation type, action types, and rule list. Each user should be registered as a task instance, and the group can consist of 1 or more instances, and task instances can belong to multiple groups. And each user and group should be associated with a specific access operation, including create, read, write, and delete, and execute. And these are access operation type can be permitted or denied. The final module is the operator audit module, and the large language model assisted network management should provide the operator with generated network configuration, confidence score, and some necessary error messages. And the network human operator should perform the audit process on the results, including result verification, compliance check, and security verification, and some necessary suggestions and corrections. And they should also record the audit time step, the large language model task instance ID, operator decisions, including approval, rejection, modification, or pending, and the final executed command and configurations. We also give a definition of the data model of the interface, which follows the previous slides, and so we can pass the 2 slides quickly. We also consider some security issues in our drafts that include the model hallucination or training data poisoning. For the future work and future research questions, so we will consider how to standardize the task instance management interface and standardize the audit process and the mutual interface between the human operator and the network management system. And we also consider to integrate the internet-based network into the interactive interface. Okay, that's all my presentation, and we welcome collaborators on this draft. Thank you.
Thank you. Can you maybe go back just 1 slide, because you have also interesting future work on that. Just go back 1 slide. Oh, okay. Yeah. So we are a bit short on time. I don't think we will have proper time to go through the discussion point, but it was also addressed through the different the 3 previous draft discussion. So just a bit of situation on my side on this topic. I have two main recommendations I'd like to give to the different authors looking into the use of especially GenAI for network management and operation. I would say first and foremost will be to try to separate very well the standardization-oriented work from the research-oriented work. That's very useful to be clear when you come here or in other associated groups. What are you going to talk about? I don't think it will be tractable to bring always the full picture in the presentation and in the discussion. The second thing is, I think through the discussion and the presentation, we have seen quite interesting aspects, but I also feel that sometimes we tend to go a bit more towards some kind of architecture proposal or even maybe some kind of solutions. I will let's take a step back and try to also refine and articulate very well a number of research questions or research challenges that altogether we see convergence. Okay, there may be 2, 3, or 5 of them, but try to see from the different proposals actually what could be common and try to write them down. Say, these are the things that we identify will be a good starting point to drive the research questions. And then that will be also, I think, how the work can proceed. It doesn't mean, I mean, the documents, the draft can remain, but at least from how we approach this in the group, I would recommend that going to this initial step of really be clear about the research question and challenges will help a lot to give clarity on what needs to be discussed and let's say, keep a good view on that instead of having too much, I would say, content and a too big scope. So I let also Jérôme, maybe if he has some views on this, and I think if we still have time, Marco, you can come, but we have to see.
Yeah, I agree with Laurent on that, and I think it's important because we understand there is this this activity is growing a bit regarding this GenAI and agent-based for network management. And what we see is that, yes, we try to make directly big architecture sometimes or made unified framework. I think it will be important also to, as Laurent said, to go back to smaller step or also try to show some implementation, some work showing, oh, this can work in practice on some part. We do not need to have, at the beginning, this framework that can do everything, I would say, or architecture. And just to comment just on your future work, I think, it's good that you articulate research question. If you look at the point here, if your goal is really to go for standardization, it's not really the purpose of, it's not the purpose of the research group.
Okay, thank you for your comments, and we will refine the draft both on the research questions and the architecture. Thank you.
Thank you very much. Thanks everyone for the participation. We're already a bit over time. Thanks everyone, and catch you up in the next NMRG meetings.
Thanks, guys.